We are in the European Space Agency presenting the final review of the VDEA project, in which we have developed a 7-meter-long deployable antenna for future Earth observation applications. ESA, as the prime contractor in a consortium with other European companies, has completed the development of a deployable antenna for future Earth observation applications. Specifically, this radar antenna will work at VHF frequency band from 40 to 50 MHz with 10 MHz bandwidth, and which will enable to map the water content in different submersion systems and underground aquifers. We can say that this antenna is a cutting-edge deployable antenna solution when stowage occupies 40 cm and when the project reaches 7-meter length. Each deployable boom is comprised by 4 longer arms and more than 150 buttons, fittings, different types of tensors, and other elements, which require precise engineering, manufacturing, and assembly to ensure optimal deployment performance. Material has been also precisely selected to ensure high power handling required by the mission. And for sure, antenna situation has been also a key point in the antenna design.
The most challenging part of this project has been to bring into reality a design which was started from scratch. And it has been a very good accomplishment for us, seeing how this long deployable structure finally deploys after a short period of development, and it is successful with all the requirements that it is needed for the mission.
Last but not least, the characterization of such large antenna has been also a challenge. It was the first time a drone-based technology was used to measure the radiation pattern at VHF frequency band. The tests were done outdoor in an location selected to avoid any kind of interference with the antenna performance. At the conclusion of the project, we have demonstrated that the antenna was working properly in the desired VHF frequency band with dual circular polarization, and the measured copolar-consular pattern agrees with the simulation.
And there were several innovations needed here in the project. The first innovation, of course, was using drones for antenna measurement. That in itself is an innovation. But for this project, we also needed to develop a mini probe, lightweight enough to carry on a drone, which you have to take into account that we were dealing with wavelengths of 6 to 7 meters. And the last innovation was the use of multi-frequencies, several frequencies in parallel in the measurement. Without that, this would not have been possible.
It has been a pleasure to participate and lead this consortium towards this successful deployable antenna solution.